Every table needs a reliable way to identify a single row. In this video we go under the hood of primary keys in Postgres, what the engine actually builds, and how to spot the classic mistake in a code review. A primary key is just two constraints in one. The column must never be null, and every value must be unique across the table. Postgres enforces this automatically by building a B-tree index the moment you declare the key. Natural keys feel convenient until the data changes. An email update means fixing every foreign key that referenced it. Surrogate keys sidestep that entirely. And when you generate them, prefer identity columns over the older serial pseudotype. Identity columns are SQL standard and harder to accidentally override. Postgres stores the primary key index separately from the heap. When a row is updated, the old tuple is marked dead and a new tuple is written. The index is updated to point at the new physical location. This is why keeping primary keys narrow and immutable matters for write performance. We create a table using an identity column as the primary key, then query the catalog to see what Postgres built for us. Notice index primary is true, and the access method is B-tree. We never wrote create index anywhere. With serial, nothing stops a caller from supplying an explicit ID and colliding with future sequence values. Generated always AS identity rejects that at the database level. The modern approach makes accidental key conflicts much harder to introduce. When you see serial in a pull request, flag it. The identity column syntax is the SQL standard replacement. It prevents manual overrides, keeps the sequence tightly bound to the column, and signals intent clearly to every future reader of the schema. 3 things to carry into your next review. Watch for redundant indexes on primary key columns. Swap any serial for an identity column, and question every natural key on whether it can ever change. Those 3 checks catch the vast majority of primary key bugs in the wild.